Okay. Good morning, Bengaluru. How are you guys doing? Okay, good. Some more noise, please. Good morning. Okay, good. So welcome to MLDS 2025. Thanks, Purvi. So it's indeed an honor to be here, and that too, first session in Hall 2 on sustainability. You guys might be wondering, okay, I come to MLDS conference, what are we talking about? So in the era of machine learning, this is Sivakumar from Johnson Controls, a human still trying to learn, catch up with things with the rapidly changing pace in technology, right? So the moment I say, yes, I know something, I'm already outdated. So like most of you, I am an AI guy, but unlike most of you, I would claim myself as AI ignorant because the pace at which the technology changes is so rapid, right? So we talked about DeepSeek just a week ago, and then we had deep research, and then AI operators or whatnot. It's changing very, very fast. So today we are going to discuss about an important topic which we as a collective community have to come and contribute, right? So this is not about Johnson Controls, not about OpenBlue, not about FM systems, but very important topic on how do we leverage AI in order to drive net zero, energy efficiency, and sustainability, right? Particularly in the context of commercial buildings. How many of you just listened to World Economic Forum in Davos 2025 last week? Good. So if you happen to listen to most of the world leaders, both the government leaders and the technology leaders, there wouldn't be any topic without the term sustainability and AI. And those guys call AI and sustainability as the power couple, right? So we are in a crucial situation. If you closely observe all the hyperscalers, all their net zero goals, they have right shifted. Some said 2030, now they are moving to 2040. Some are saying 2040, and now they are moving to 2050. And they're doing various stuff, right? So they wanted to build data center in underwater. Some, the startups wanted to build data centers in the space. So a lot of things happening. But because of the AI momentum which the world is seeing, there is a urgent need for us to really look at how do we drive energy efficiency and decarbonize and help our planet to be more sustainable. So that is why this topic is more important, and thanks for making this as the first topic. I know there are many other topics like agentic AI, etc., but this is very, very important for the planet, for us, and we as a community can really make a change. Now, just to set the context, right? So Johnson Controls, we're in the business of technology for buildings, industrial automation, etc. But I just wanted to lay this out. So how do we accelerate transformation to smart, autonomous buildings, right? Each adjective has its own name, and we'll go through what it is, right? So gone are the days where we had legacy buildings, standalones, no sensors, no data collected or whatnot. And then we moved to connected buildings maybe 15, 20 years ago. We have a simple dashboard and optimize for energy. You collect energy parameters. And then two or more systems manually getting integrated, right? And then we moved on to smart buildings, where it is becoming more intelligent, highly coordinated. And also AI was emerging 5, 6 years ago. There have been FDD, fault detection and diagnostics, rule-based AI, and now we are in the era of data-driven AI. So AI has been existing for a while, and most building systems integrated with discovery and also some of the cloud integrations. So that is how the smart building got evolved, and now we are somewhere here from an industry perspective. Now with the advent of AI and agentic AI, etc., we are into autonomous buildings, which means there are autonomous workflows. We can really look at with human in the loop and without human in the loop. We'll look at it, what has been our journey. And also advanced AI, really looking at now with during COVID and post-COVID, it's very, very important to maintain the indoor air quality as well, right? There's a comfort set point. There's also another area where we need to manage energy costs. It's a delicate balance. So that is why advanced AI also come into picture. And then how does a building can learn and adapt? Like we learn and adapt to various technologies. Can buildings listen to the data, what it's able to sensorize, and then adapt to itself, and all systems, depending upon what type of building, either it's on-site or on cloud. So far, is it okay if I'm too fast or too slow? Please raise your hand so that I can adjust myself. So far, are we good? Okay. Now, why we wanted to have this topic today and why we wanted to discuss net zero energy efficiency, it's very, very important. If you really look at, buildings contribute nearly 40% of the global emissions, right? We know, we have wildfires in LA, we have snow in Dallas, and similarly in India, different parts of the world, unpredictable weather conditions, all because of climate change, and major contributors are these carbon emissions. And today, what we are talking about is only one subset of overall emissions. And that is buildings. Buildings contribute 40% of the emissions, right? Even if we try to address this, I think we will have a significant movement in our journey towards net zero and making our planet more sustainable. And all can be accelerated and done through digital solutions, leveraging the data and the AI. And with the trifecta of efficiency, here we are talking about energy efficiency, and then electrification and digitalization. So we can slash carbon and operating costs. So this is why this topic is more important, not only within this auditorium, but we as community, how leveraging AI, we can solve world problems so that we can make our planet much better. And for future generations to come, we give them a healthier environment to live. Now there are several definitions of AI. We will also go through what it is. So AI means different things to different people. So there are several definitions. You chat GPT, you Google search it, you Perplexity AI, there are several going on. So what has been our experience is, have a maniacal focus on the what. Once we understand the problem, then there are several areas of how to solve it. So focus on what, not the how, to start with. That has been our experience. And I have a couple of my colleagues also with me, Pragati and Gaurav from Johnson Controls. At the end, you can be able to interact. Now, so AI revolution, it has not been an evolution, it has been a revolution. The things are changing so fast, we discussed. So it's a machine's ability to perform cognitive functions which usually associate with human minds. We all know this. You guys are experts in that. I need not define that. But what's happening is, it has the potential to reshape the global economy and also really look at how it's going to impact the labor market, right? So that's very, very important. In this case, for example, a technician inside a building who is going to maintain your chiller. So you're able to have a comfortable seating here because somebody else is maintaining the air conditioning in this building, right? So how is his or her life is going to change with advent of AI? And then AI has become an integral part of daily lives. And then global spending, $300 billion. We don't even know how many $billion, right? There are several research reports suggesting, and also can solve really hard aspirational problems. Now, what does the market talk about, right? So particularly in the context of buildings, so 60% of enterprise smart space application, right? So now we are in a, how many of you go to office 5 days a week? Okay, good. At least 50% of the crowd, which is good. And remaining 50%, maybe 3 days, 2 days, etc. Right? So how does the facility manager manage the space, right? So we need to have smart space offerings. So what one of the Gartner reports says, by 2026, the smart space application will have 60% of AI features on the edge devices. It could be a smart devices or industrial rugged devices, depending upon where you guys are working on. And by 2027, 80% of urban commercial real estate buildings will become energy positive, right? So all these are bold statements, easier to say, tough to do. And by 2030, 80% of smart space solutions will support renewable energy supply management, right? All these are nice statements, nice research reports any consulting companies can give. But to be pragmatic, we do have concerns. Number one, the trust and traceability of data, right? This is just not business data. This is about data about the buildings, the occupants of a building. We need to ensure the privacy is protected, etc. And security of the building and individual data, right? You just imagine data center as a building, right? We are hosting customer data, whether it's a data center or your GCCs or your IT service providers. How do we ensure both the IT network and OT networks are secure, right? Role of human operators in the paradigm of AI-driven system. Should we have in the loop? Should we not in the loop? Right? So just for an example, a surgery is going on within a hospital, right? Can we afford to be in full autonomous mode? It's scary, right? Even with human intervention, because of lack of proper moisture and air conditioning, several operations fail, right? So it depends on what type of building, what type of energy we really wanted to use. And new skill sets and system integrations required to make effective use of AI. Now, in the context of smart buildings, we just wanted to focus on what it means, right? Again, I'm aware that we are in Machine Learning Summit. We are talking about data and AI. I'll soon come into this. Obviously, data-driven. Why we have put this is so obvious, right? I mean, you may say, hey, Siva, what are you talking about? I mean, we all know we are techno geeks. We know everything is data. But in the world of industrial IoT, there are non-data-driven AI as well, which are rule-based, which is FTD, fault detection and diagnostic based. Now we are talking about data-driven approaches, time series measurements, images, text, etc., and also respond to different inputs and different outputs as well. And then automated, works automatically without constant manual intervention. Please note, without constant manual intervention, which means depending upon the criticality, at times we need manual intervention as well. And then possibly with a human in the loop. And third is, it is capable, right? As good as or even better than the human ability. That's when the end customers will realize the value. Otherwise, if you're going to sell, hey, I have an AI-driven solution, can you take it? They will ask, okay, is it going to be cheaper, faster, better, or employee experience is going to be better? That's the question they're going to ask. And goes beyond conventional procedures or methods. And at the end of the day, it should be beneficial, repeatable, positive outcomes to the end users, and also so more efficiently and cheaper than alternative methods. Are we on same page? Is speed okay? Now, most of you come from reputed organizations or startups. Any AI program or a product development shall anchor upon core principles. So from a smart building context, this is one point of view where we say, hey, choose the right algorithm for the right application. We may not really look at best of breed algorithms, but what best fits the need to solve a particular use case. Number two, support existing control systems and augment new deployments, because all of your sensors and industrial IoT devices, it has to work with the control systems, and then on top of it, all your cloud and AI layer comes in. So it has to co-mingle with the existing control system. That is very important. And third one, deliver capabilities, because technically speaking, we can do everything, right? But we only have limited capacity, whether you are in a pod structure or scrum teams or whatnot, but based upon the business priority and value driven for which the customer is willing to pay, we need to pick and choose what we are trying to develop. And then keep humans always in control and optimally in loop, and then collect feedback and continuous learning and improvement. So these are the core principles with which we are discussing about autonomous buildings leveraging AI. Now, our perspective, I talked about just earlier. So should we have human in the loop? Should we have full automation? It's not and or either or. It depends upon the type of applications, right? So when human in the loop is needed, I mean, be very concise on the generative AI summary, and then backed by the quantitative data, and recommend what actions that human in the loop can take. Otherwise, if we flood them with data, they may even ignore. For example, there are going to be n number of alerts saying that, hey, your temperature is shot up. That maintenance technician sees it, every day for almost a year, right? They may say, okay, and not a problem at all. So it's very, very important to be very concise and actionable recommendations to be given. Those things can be preferred for high risk, low frequency application. And when we go for full automation, within constraints, because we need to put the boundaries, we cannot just say, hey, you do whatever you want. At the same time, with active monitoring and support overrides as a fallback mechanism. So this can be deployed low risk and high frequency application, right? We will take one example each when we talk about in which scenario we can really deploy what kind of automation, right? For example, in hospital, when a particularly surgery is going on, we don't want to get into full automation mode at all, right? Maybe when a cricket match is going on in a stadium which has both indoor and outdoors, maybe you can go for this, right? I mean, anyway, you're going to sweat depending upon which city it's getting played upon. So that you can afford to do full automation, just as an example, right? So we need to pick and choose the type of energy, the type of building, and the type of audience we are looking at. So let the user change the modes based on the preference so that we empower the end user, and also automatically suggest switching modes based upon the choices and outcomes. So this is where that AI and generative AI comes in. How do we generate those contextual specific recommendations to the end user? Now, so any new technology or any new projects has its own risks, right? And without taking risk, I don't think so India, a startup ecosystem, would have had so many unicorns, etc. So we are demonstrating our intelligent risk-taking ability. So this chart is very important to understand. Let's acknowledge there are risks, and how do we really look at in what scenarios, what type of risk we can take. So risk on the y-axis low to high, and the frequency on x-axis low to high, right? Guardrails balance action frequency while allowing for user intervention. So if the risks are high and the frequency is low, keep human in the loop to validate actions, which we discussed in the previous slide. If the risk is kind of medium, let user choose between manual and automated mode depending upon the context. And then when low risk, high frequency, adjust automatically, but always have an override option, which is the manual disable. And then avoid AI for now when risks are too high and frequency is also high. And then configure bounds and active monitoring, right? These are all the generic guidelines. Coming to the specifics, what use cases? Let's say you want to do plan for long-term sustainability goals, like some of the hyperscalers did. So always high risk involvement, right? So first they said 2030, now they're telling no, 2040. By the time the new president of US came in, they're withdrawing from Paris Agreement. There's so much risk involved, right? So that's when you'll have to choose this. And people and amenities for optimal space utilization, we need to be very careful, because this is not just business data. This could be impactful to the occupants' lives of the building. Whereas medium risk, temperature setback, intelligent lighting management, and then curtailment of demand response events, etc. Let's say during MLDS event, the demand of energy could be high because several thousand people are attending. On other days, it could be lesser. So those things we can handle it here. And particularly high risk, high frequency, safety critical application and regulatory control loops. And then on the other side, typical high frequency, low risk would be AHU, temperature reset, water side, and alarm management. Now we talked about what are all the risks. So now let's come to across the building life cycle, what opportunities we have, right? When we construct a building, either greenfield or brownfield, we construct, we commission, we monitor, we control, we maintain, and then we do some retrofits, right? This is the typical life cycle. But today what we are going to focus is on the operation side, what are all the possibilities, how can we drive efficiencies and drive net zero leveraging AI, right? So personalization, build ask me anything for accessing insights, instead of the technician going and clicking the data and saying that what it is, how do we make them more user-friendly? And also have a chatbot. These are all common things which everybody would have worked. but autonomous for comfort, right? Depending upon your comfort setting, depending upon what environment you are in and the weather condition outside, how do you enable that autonomous feature? That's very, very important. And then post-COVID, indoor air quality has become very, very important, not just from a comfort perspective, but also from a health perspective, right? So how do you really look at the occupants' comfort level vis-a-vis the facility manager's goal to control cost by controlling the energy? It's a delicate balance. So that is where your optimization algorithm and AI comes into picture, give recommendations to us. And then autonomous smart facility management, particularly having tech support and also automated workflows, etc. And then particularly huge chillers for such a large facility, we really need to look at how we can optimize those. So these are all the opportunities what we are going to focus. But apart from that, there are other opportunities as well, both during retrofit and construction and commissioning phases. But why we are not looking at is, these are called design time, right? Design time opportunities, but what we are focusing now is during operation time activities. Okay, thanks to all the consulting companies here, Gartner, KPMG, Deloitte. Sorry for, it's a bit blurred, but what we are trying to do is, what is the AI maturity model for building technologies, right? So phase one, I mean, some of the customers who are owners of commercial estate building, they are not digitally savvy yet. They try to kind of say, okay, I'm AI aware, I don't want to take much risk, let me do a pilot. And then they look at some efficiencies, let's say 50%, low to moderate data quality, etc. And then phase three is where they really deploy AI to really generate operational efficiencies. And all these are not PowerPoint slides or theories. As we speak, there are companies, including us and others, who have deployed these solutions in India, for example, within Bangalore, for large commercial real estate buildings. So, and they are able to generate savings, right? And then phase four is AI-driven business transformation. How do we build the cost savings and high complexity and data security requirements? And then now we are somewhere here between these two, if you will, but long way to go in terms of fully autonomous. Should we go is another question. Now we talked about, hey, these are all the risks, these are all the market opportunities, etc. But how do we crystallize, okay, what should we do, right? How do we go about? So this is where we are talking about using AI is becoming the new normal. If we don't use AI, then we become abnormal. So that's the world we are living in, right? So ChatGPT AI as co-pilot has become pervasive, exponential explosion of data, industry beginning to productionize AI. So I just wanted to have a quick question. How many of, what is the hit rate of your models which is going to production? Let's say you develop 10 models. How many of the models are going to production? Any idea? How many of you say all the models I developed have gone to production? 100%? Anybody? Okay. At least 50% of the models which I develop are going to production and is being used. Anybody? Right? So, yeah, so very few, right? So, because we are still in an early stage, I mean, ability to take risk and maturity is also, we are getting there. So that's why it's very important to understand, yes, we are getting to productionize AI, but we need to accelerate it. And today, whether it really gives value or not, both at a board level and shareholders level, AI is becoming a business imperative. Now, in order to do this, what all we can impact? The end consumer or customer experience, our internal workforce productivity, not just our knowledge workers, but also the brown-collared workers in the maintenance rooms, intelligent products like smart autonomous buildings, and AI-enabled services. Now, data strategy, you all know, is enabler for AI capabilities. We need not deliberate there. But value management is very, very important. Why most of the models are not going to production and hit rate is pretty still low? Because we as tech community, we wanted to do more. But when we go to a CFO or a venture capitalist and pitch saying that, hey, this is what I'm doing, and that's it. Within 5 minutes, the conversation gets over because the articulation of value is very, very critical and tough to do. So that's very, very important. Value-based AI reinvention addressing core business initiatives. Now, we all would have heard and talked about within our organization and startups, okay guys, all this slide strategy, risks and all is okay, but what is the outcome? So here we're going to share a few examples of what we have done during our work life for our end customers. This is where we are talking really about AI and how we have deployed it. Right? Optimize the performance of buildings with measurable outcomes in 4 dimensions. Energy efficiency and sustainability, space, internal space and well-being and productivity, and operational efficiency of the equipments, because all your equipment like chillers, etc., are capital intensive, and we need to do our best to extend the life of it, and then security, safety, and compliance. Yeah, so what are all the autonomous capabilities we are looking at design and control intelligence level, operational recommendations, autonomous control panel, workflow-powered SOP engines, and occupation-facing generative AI, right, which is very, very important. And at a continuous learning and optimization level, we are looking at energy and carbon prediction improvements, chiller plant, airside optimization, clean air optimization, and most importantly, worker safety monitoring in an industrial building scenario. Building connectivity, configuration, AI-powered workflow, I mean, these are common, no need of, these are fundamentals. Now, the same thing in a different lens we have put in. Now let's get into the real crux of the topic, right? So how do we predict energy use and demand with consumption of thresholds and alerts? So this is a live example in one of our customer side. There are also other solutions available. Here what we are really doing is use the data of the utilities from the buildings and use RNNs and LSTMs to really predict what the energy demand is. And why LSTM? You all know that so we are dealing with time series data here. And LSTMs are very good in handling the temporal aspects of it. How do you take a chunk of data, time series data, a long sequence, and through the memory capacity what they have for extended period of time, how can they remember it? For example, let's say MLDS event is happening in Nimitz, and today the energy demand could be peaked up, right? How do they understand that time series event with peaks and troughs? So that's why LSTM really, really differentiate. There are other algorithms also, but LSTM for this use case, we found it very, very useful, particularly handling the temporal dimensions as well. And when we set the consumption threshold, and what happens is we tend to predict based upon the outdoor weather conditions and the occupancy of this building and the baseline data. So this is how the prediction comes in, and using generative AI, we filter those based upon what prompt the technician wants to really look at. We apply algorithms and then recommend vital few actions so that they can, once they take, they're able to predict the energy usage and thereby reduce the energy bills. So this is very, very important, and we have deployed for about across the globe for 10 to 12 large customers, and each one of them having the portfolio of buildings across the globe. So first, set consumption threshold, inspect energy use by floor, and use floors based on data. Not just the building, but also at a floor level, all based on data. The next one is, we also have something called NetZero Advisor, because it's very, very important both for the technical maintenance person and also the facility manager who is in charge of the operational cost to recommend them how do we achieve net zero. So we adopt two techniques here. So we do something called lean energy analysis using inverse model. What it does is, number one, looks at the historical utility data and then say, this is where you are today. right? Using regression model and inversion model, we build that out. And then secondly, what it also tells is, okay, based upon your historical data, how your peer buildings, your building's neighborhood, based upon data available from the data service providers, how do you benchmark yourself? So this is step number 2, right? So that's where this NetZero advisor really comes into picture, not only looking inside ourselves, but also benchmarking with other buildings in and around. And thirdly, it really recommends what are all the energy saving opportunities or projects available. And then once that is done, then using generative AI, converting into natural language, in a language that is easily understandable by the persona, which is technician here, it says, these are all the projects to be taken. So this is where and how we really apply AI and generative AI in a specific use case to solve the end customer problem. I know there are many people waiting, so it's just going to take another 10 minutes. Thank you for your patient listening. We'll just keep going. Now, I also talked about, in addition to energy efficiency and sustainability, it's very important, particularly in today's day and age, how do we balance the indoor air quality, right? So which in turn has the indirect impact on how the quality of air and the sustainability as well. Here what we use physics-based modeling, which has been there for several decades, where we talk about how the airflow has to be from the ducts so that it can retain certain amount of moisture or humidity, etc. Or in a semiconductor kind of manufacturing, there are micron, millidust particle kind of environment. So there are physics-based modeling available. But here what we are talking about is, how do we really look at a data-driven approach whereby we take the heat generated by all of us, right? So when so many human beings are inside that, there are sources of heat, and also there are equipments like these displays which also generates heat. So take this data as well and also compare it with the source of other heat available from the HVAC equipments, and then really using machine learning methods correlate with the outdoor weather temperature, and then come out with a recommendation, really filtering out, because there could be certain points where your comfort could be compromised. Let's say if I blow too much of air, then you might fight cold. If I turn off the AC, then there would be air circulation, right? We have certain constraints on comfort. While retaining the comfort level, how do we optimize the energy? So that is where the machine learning models comes into picture. It analyzes and correlates the data between the occupants, the occupancy, the external weather conditions, and the internal utilization of the data, and then recommends, hey, how do we bring in the indoor air quality? And that's where you will see it's not that visible. So you will see the left hand, what is the simulated condition, and then 3 recommendations with how do you balance cost versus comfort. So system triggered optimization and measure the energy savings. So finally, we do have 6 minutes. We'll have some time for Q&A. So autonomous controls, energy optimization. This is where I talked about in the previous slide. We are moving slowly from smart to autonomous. When we had a voice of a customer study, we said, okay, generative AI, do prompt engineering, but the technician and the basement, they didn't want to do prompt at all. So they want to eliminate the prompt engineering itself. So that's where we thought about, okay, we talk about generative AI, we say prompt engineering, but they don't want to do that. So that's when it made us to think, how do we move from smart to autonomous, of course, with guardrails and controls in place, and then see how do we establish a workflow and actuate those actions recommended so that we can move into autonomous building. This we have to be very careful. We are in an early stage, but we are able to realize with 2 weeks in autonomous mode in Bangalore, in one of the large commercial estate, we were able to save 12,000 rupees. I know it's very small, but we have to be very careful in the autonomous mode based upon the type of building we are looking at. So we have optimized zone transition, system occupied or whatnot. We have several indicators: comfort, too hot, too cold, too dirty, and also AI-based temperature predictions and KPI cards. So the key thing to note is there are two modes. Either an advisory mode where you won't have any benefits realized because it just recommends, and then the end user, the customer can decide whether to take action or not, depending upon the risk profile. The second one is the auto mode, which is the command mode. It has command and control. That's what I was talking about. When it is in auto mode, then the value and the energy savings can be realized, right? So this is all I had for today. So this is how the value keeps building in the smart building and autonomous building space, leveraging AI and the building management system data and the utility data. And once the value is generated, then the adoption becomes better. And the spaces and places are opening up with new possibilities. With that, I will pause, open for Q&A. And before we start the Q&A, easy questions for me, anything tough questions for my colleagues out there, Pragati and Gaurav, who are sitting here. I hope the pace was okay. I didn't go too fast or too slow. So any questions, anything related to, yeah, please. Yes.
To say, okay, hey, I want our model is recommending to apply these set points.
Yeah.
But they are very hesitant in doing so.
Yes.
I just wanted to know what has been your experience in convincing the customers, because from our side, what we eventually ended up doing was showing them that in real life, these models actually work with an actual demonstration.
Yeah. Yeah.
So what has your experience been in that field?
Yeah, very good question. Two types of audience, right? One, you interact with the consumer, which is the persona here, the technician. I mean, they don't want to do anything because the first thing what we have observed is, okay, by bringing this, is my job go away, right? Because what we have done in the boardroom with all the CFOs and the economic buyer who signs the check is, okay, by doing this, you can eliminate the labor, and thereby your your savings are achieved, right? So that's why we need to anchor on the core principles. Whatever solution we are providing, it has to be human augmented. And what we do is a lot of change management has to happen from the solution provider like us, and also from their management saying that, hey, this is the journey we are going through. These are all the benefits you will get, and you will become more digitally savvy and upskill yourself. It's not a switch. It takes a lot of time, sometimes weeks, sometimes month. Once their technician understands that, yes, this is my aha moment, then the adoption comes in and they become the evangelist to the rest of the technicians to adopt. But that is a very, very crucial point where both the management at the customer side and we solution providers have to come together and convince that the technician community. Otherwise, we may have a great solution with zero adoption, which we don't want to have it. Yeah, we are facing the similar challenges. It's a slow, gradual change management which we need to take it through. Any other questions on this side, to my right? Yeah?
Hello. So this is Pawan, work at Fiserv. I've got a very stupid, funny kind of a use case, but I thought I'll ask it nonetheless.
Please.
One of the simplest questions that I always have when I go into a toilet, into any professional space, is that which is the bathroom that's the most cleanest?
Okay.
Is that a use case that is being solved? Have you heard about it in the industry? I really want to know, because I think it's a billion-dollar industry that is waiting to be conquered.
Yeah. I mean, yes, we are seeing such type of use cases, not necessarily in India geography, but in the Middle East. We are solving problems for a large bank customer in Middle East, because this also, technically it is solvable, but economically is it affordable is what we are looking at. But yes, as we speak in Abu Dhabi, there's a large banking customer building where already these things are being solved. This is one use case in a pharma industry. Let's say in a hospital patient care, they wanted to control the blinds through IIoT, right? And we cannot have the patient or the caretaker to say, go get up and switch, etc., right? So that's why in a single pane of glass, not only we provide dashboards, but it does have command and control features whereby at one click you will be able to control it. Yeah, we have 12 seconds. Any last questions?
Yeah. Hi, Shivakumar. Here.
Yeah.
Yeah, to your right.
Yeah.
Hi. I'm Karthik from Johnson & Johnson.
Okay.
Very simple question, actually. So these things which you have mentioned, how difficult it would be for implementing on existing buildings?
Yeah.
And second thing is, how much adoption could be there for the residential side also? Like now it's on the commercial side.
Yes.
On the residential side also, how much of acceptance could be there?
Yeah. So first, yeah, time is up, but I'll keep it brief. We can discuss maybe later. So on a brownfield kind of a setup, it's very, the most time-consuming part is the data configuration. You have set of all buildings, your BIM models and your digital twin kind of stuff. How do we get that converted into data structure? You need it in your platform. So that's the most time-consuming, which we are going through right now. There are several startups trying to address it. So it will take easily weeks to months. So that's number one. But residential space, we do have certain premium residential properties where similar type of things are evolved, but there's a fee to pay. So in certain segment, in certain geographies, yes, it is possible and it's already there, but this cannot be for masses because it's going to cost. With that, thank you for your patient hearing, and thanks for the second reminder, Purvi.
Looks to be an enormous amount of data requirement when you internally make a profile of how much heat is generated and which is the source is generated. So does it need that we have to put many extra sensors like IR cameras and image processing techniques to get the overall data at each point, how much heat we are generating, how much heat we are going out? Or it is possible to use this solution with existing sensors without doing any hardware modification?
Yeah, good question. Our experience and my personal recommendation would be just good enough data is important, because the more sensors you're going, the more data points coming in, there are more outliers, there are more spikes. We'll spend effort to kind of massage it and make it cleaner. Just enough data, whatever we have existing, once we realize the value, then we can additional sensorization and additional data, and then we can improvise on it. But going big bang approach, putting lot of devices and collecting more data is not going to actually solve the problem. I would say in an agile methodology, iterative methodology, with existing data, generate the value and then improve upon it. That has been our experience. Thank you.
Thank you, Siva. That was lovely.
Thank you. Thank you.